Okay, we will see another experiment, shear force diagram and bend diagram, drawing for a simply supported beam carrying UDL, point load and a moment. Here you can see this diagram where this simply supported beam is subjected to one UDL, one point load and one moment. For this diagram, we will try to draw shear force and bending moments using mechanical APDL softwares. This is the environment of mechanical APDL software, and in order to solve this problem, first of all, go to preferences, structural, then preprocessor, element type, take beam element, 2D finite, and go to options, and in K3 the quadratic equation is of the form, select here cubic form. We are solving the beam problem, therefore give the material properties, structural, linear, elastic, isotropic. In this, give the Young's modulus as 2E5, Poisson's ratio 0.3. Click OK. Then go to sections, common sections, beam, common sections. Give the breadth and height of the beam. Here the breadth of the beam is 120 mm and height is 200 mm. Give the values of the beam as 120 and 200. Click OK. Now we are assigned with the material properties and also the cross section of the beam. Now we will try to create the key points. Go to modeling, create key points in active CS, create node 1 with 0, 0, 0, node 2, that is key point 2 with 3000, 0, 0, key point 3, 4500, 0, 0, key point 4, that is the final key point, 6000, 0, 0. Click OK. We have created the 4 key points, and we need to join these key points by using the lines. Go to lines, straight line, select key point 1 and 2, key point 2 and 3, and key point 3 and 4. The lines will be drawn. After drawing the lines, okay, we need to discretize these lines into various elements and perform the meshing operation. Now in order to perform that, go to meshing, size controls, manual size, lines, picked lines, pick that line, give the number of divisions as 5, apply. Okay, depending upon the number of divisions, select line 2, here also I am giving 5, select line 3, here also 5. Depending upon your requirement, you can give the number of divisions of the each line. Now after discretizing these lines, we need to perform the meshing operation. Go to mesh, picked lines, select all these lines, click OK. Then the lines are meshed. Then plot controls, go to plot key points, then the key points will be displayed. Now we need to give the boundary conditions and the loading values. See here at node A, in order to give the boundary condition, go to loads, define loads, apply, structural, displacement on nodes, select node 1 and ux, uy, uz and rotation x and rotation y as constraint. ux, uy, uz and rotation x and rotation y. Click OK. Then select the node 4, apply. Here the node 4 is constrained with uy, uz, rotation x and rotation y. uy, uz, rotation x and rotation y. Click OK. Now the given boundary conditions are applied to the beam. Now we need to apply the loading conditions. Go to structural, displacement on nodes. Okay, in order to visualize these key points, plot key points, then select key point number 2, displacement, that is force on nodes. Go to force on nodes, Fy value is how much? Minus 40 kilonewtons. It is acting in the downward direction. Minus 40 into 10 cube. Then after giving the loads, Now we need to assign the movement. Go to force or movements and take the node 3, and about not node 3, the movement is acting in the clockwise direction. Take it as negative minus 120 into 10 cube. That is the movement acting at node 3. About z direction, click apply. Here the movement is applied and also the vertical load is applied at node 2. Now we need to apply the uniformly distributed load on the beam. Now in order to apply that uniformly distributed load, go to pressure on beams. Now we need to select the node 1 and 2. Okay, before selecting the node 1 and 2, here various options are there. Now we can give the pressure by using the box type of pressure between these two nodes, between node 1 and node 2, pressure on beams. Click icon box and you can select the pressure between node 1 and node 2. You can drag that one by using your mouse and you can give that box type of pressure between these nodes, and that is the pressure is uniformly distributed. That's why at ith node and jth node I am giving the equal magnitude here, that is 20 and here also 20. I have converted that value into mm's, and 20 and 20 Newton per mm. Click apply. Now the pressure is given and also the point load is finished, and also the movement at node 3 is also finished. Now this figure is a complete figure with boundary conditions and also the distributed loads. Now it is ready to solve. Now in order to solve this problem, solve current LS, and the solution is done. Now after this solution is done, you need to go to the general post processor to view the results, nodal solution and displacement vector sum. If you click, then you can observe the deformation of the entire beam against the loading conditions. You can see here the beam is subjected to, I think, between nodes 2 and 3. It is subjected to severe deformation. The value is 4.22 mm, 4.75 mm. The maximum is 4.75 mm. From 4.22 to 4.75 mm, that is the maximum displacement occurred in the beam against the loading conditions. Now if you wanted to view the shear force distribution and bending moment distribution, then go to here. In order to view the reaction forces, go to list results, reaction solution, then you can observe the reactions produced in the beam. And if you wanted to view shear force distribution and bending moment distribution, then you need to define the table initially to view the shear force and bending moment diagram distribution. In order to define those tables, initially we need to type, close this box, set L step in the dialog box provided at the top of the window and press enter. Set L step and press enter. Then after that, go to element table, define table. Here you can give SFD shear force diagram by sequence number SMISC 5, and again SFD1 I have given by sequence number I am giving 18. Click apply. And bending moment diagram BMD by sequence number SMISC 2, and again here BMD1, just I am giving at ith node and jth node by sequence number SMISC 15. Therefore 5 and 18 are related to shear force distribution, 2 and 15 are related to bending moment diagram distribution. Then we can go to the plot results, line element results, select SFD and SFD1, and undeformed shape, then you can observe the shear force distribution across the beam, how the shear forces are distributed. Okay, the values are displayed at each and every node, how the shear force distribution takes place. And if you wanted to view the bending moment diagram distribution, then go to line element results, take BMD and BMD1 at ith node and jth node, then click OK. Then you can observe the maximum bending moment produced in the beam. Maximum bending moment produced in the beam, you can observe it is indicated with the red color region, and you can take down this value bending moment in Newton mm for calculating the bending stress induced in the beam. You can compare this value with the analytical results. Okay, like this you will be able to determine the deformations, reaction forces, elemental solution, shear force diagram distribution and bending moment diagram distribution for any type of beam easily by using Ansys Mechanical APDL software. You can also see the animation of the figure, how the deformation takes place in the entire structure. You can also see the one measure stresses. Go to elemental solution, one measure stresses distribution, and if you click OK, then the one measure stresses distribution for each element will be displayed. Okay, like this, you can calculate various values for a beam subjected to loading conditions. You can also animate this. Go to plot controls, animate the deformed shape, deformed plus undeformed, and you can check the animated view with light blue color, how the deformation is encountered in the beam. Okay, in this way you can determine easily by using the Ansys Mechanical APDL software various values of deformations, and you can also see those results. Thank you.